Hello everyone. In this lecture, you are going to learn about heat engine. So let's get started. So we are going to learn about heat engine topic in this lecture. So heat engine, this topic is very important in thermodynamics and your school physics. So based on this, there will be n number of sums you have to solve. So let us know about its basic working and its efficiency formula to solve the problems. Heat engine. So heat engine is a device that produce a net output by absorbing the amount of heat from a high temperature reservoir and rejecting it to a low temperature reservoir. So let me draw uh, the diagram that represents the working of the heat engine. So this can certainly help you out to find out the correct one. So let us take this as TH. This is high temperature reservoir. Okay, it is producing QH amount of heat from the high temperature reservoir to heat engine. To the heat engine, it is providing the QH amount of heat from high temperature reservoir, producing a work output by rejecting the some amount of heat to the lower temperature reservoir. It is rejecting some amount of heat to low temperature reservoir. So it is taking in input as QH. Okay, QH is nothing but heat from the high temperature reservoir and rejecting the QL, the heat that is rejected from the heat engine to the low temperature reservoir. By this, it is producing a work output. So in this way, the heat engine works. So heat engine, you have to remember that it will provide some net work by taking in the absorption of heat. So this is the concept employed in the heat engine. Now we are going to learn about its efficiency. Before learning about its efficiency, let's make use of the first law of thermodynamics. Okay, so why we have to use the first law of thermodynamics in this sense? First law of thermodynamics, what? Energy conservation. It speaks of what? It speaks of the energy conservation. So let's use that one. So thermodynamics, energy conservation. Okay, so if you do the energy balance, now we can find out the first law equation for this heat engine. So how you are going to do what? You are going to do the energy balance. So you are going to do energy balance. So energy balance, when you see energy balance, see, wait, let me complete this. Yes, energy balance. So when you see energy balance, what are all the things are coming, given us the input to the heat engine? Only QH. So QH will be in positive sign. Okay, QH will be in positive sign. What is going out from the heat engine? Work is going out from the heat engine, and the lower temperature reservoir, the heat that is rejected to the lower temperature reservoir is going out. Okay, work and the heat rejected to the lower temperature reservoir is going out. Now energy balance equation, that's all we have completed. So from this, what can we conclude? We can conclude that W out, that is the work output, is equal to absorption of heat from lower temperature to the rejection of heat from the low temperature reservoir. So this equation we have. So keep this equation in mind. This equation will sequentially be helpful in the solving sums. Okay. So now let us speak about actual thing, that is efficiency. So it is performance of this heat engine is measured by efficiency. So what do you mean by efficiency? Efficiency is nothing but the output divided by input. What is that? Output divided by input. Okay. So in this engine, what is the output? In this engine, the output is workout. This part is known as the output part. Okay. This part is known as the output part. Okay. So no doubt in this. Okay. Which is the input to the heat engine. This QH part is known as the input part. Okay. This QH part is known as the input part. So then, what about this QL? We are not accounting this either as input or output. Then this is the rejected part. Okay, this is something that is rejected, neither an output nor an input. But during energy balance, we should take QL. But during the efficiency calculation, this will behave as a rejected part. But by derivation, we will bring that also into contact. That you will be seeing now. This is what rejected part. Okay. This is the rejected part. Now I told eta is equal to output. Efficiency is equal to output divided by input. Now let us expand this with proper notation. Output is what I told it as work output. Okay. Work output divided by input is what? The heat that is transferred from high temperature reservoir QH. Okay. Now, how can you write this W out? We know that the work output is equal to the high temperature reservoir's heat minus low temperature reservoir's heat. So, expand this in term of that. So, how can you expand? QH minus QL divided by QH. Okay. Further simplifying it. Okay. H. Okay. So if I simplify this, what I will be getting as a final equation in the sense, so the efficiency of the heat engine is equal to 1 minus low temperatures heat transfer divided by the higher temperature reservoirs heat that is absorbed. So this is what the final equation, and hence we have brought an equation for the efficiency of heat engine. So this equation and this equation will play a subsequent role in solving problems with respect to heat engine. So as a summary, what you have to know in the sense, heat engine will provide some work output by getting input as the heat that from the high temperature reservoir. This is the thing you have to have in the mind, and by this you can remember all these things and you can apply this. So thank you for watching. Let's continue with the refrigerator and heat pump in upcoming videos. Thank you.